Yeah, okay, that's not a problem. Okay, no problem. Okay, so it seems like everybody here knows how to do the basic operations of fraction quite well, actually. Obviously, for division, you're multiplying by the reciprocal, right? Everybody knows that as well. So therefore, there's really no need to do any more examples for it, I think, because if you know multiplication, you should know division, okay? They're all the same thing. They really like to show it in visuals. At high school, I don't think you'll be required to do this, okay? You can solve it pretty much whatever way you want, and your teacher will give you the mark. But my recommendation is, yeah, for example, for something like this, I still recommend writing as an improper fraction first, okay? So 5 and 1/2 can be written as 11/2. We need to divide by 9/10, which is multiplied by 10/9. 10 and 2 can be simplified to 5 and 1. So my final answer is 55/9. I would think this answer is acceptable, but depending on the teacher that you have in grade 9, it's probably safer to write it as a mixed fraction. So it's probably better for you to write it like this. Okay. Oh, no, wait. Did I do that right? No, that's wrong. 6 and 1, right? Sorry about that, guys. Okay. So afterwards, once you have the improper fraction, try to convert it back to the mixed number. Everybody knows how to convert from mixed improper fraction to mixed number, right? I shouldn't need to explain this. Everyone's okay? Yes. Okay, good. What about Charlie and Karina? I haven't heard any comments from you guys. Are you guys able to keep up? This is all easy for you guys? Charlie, Karina? Karina is okay. Karina, what grade are you going to? You're going into grade 8 or grade 7 maybe? Grade 8, okay. And Charlie? I haven't heard anything from Charlie. Nah, okay. So again, this is all grade 8 and grade 7 review, I would say. It's fairly straightforward. You're going into grade 7, Charlie? Okay. So yeah, we have a lot of very young students here, but all of you guys have very good math fundamentals because you guys all know how to do this very, very well. So good job. Kudos to you guys. Integer operations tends to be, it's easy for most students, but students always tend to make one mistake, and that's with this one over here. I always see students making this mistake. So let's try solving this equation, okay? We have -2 to the power of 4 plus -1, take away 1, cube, plus 5 times -4 to the power of 4. We're going to try the first step. Do first. Everybody here has learned order of operations already because the youngest in our classroom today is grade 6, and yeah, should be recording. Okay. Okay. The answer 56. I'm not 100% sure. Oh, it says right over here, 56. So yes, you're correct, Eric. So again, I haven't worked it out myself, so I don't know if the answer is 56. But Eric, since you got the answer of 56, you must have realized that this part over here is -16, right? This is the part that I think everybody else would get everything correct. I think this component here is not a problem for anyone, but everybody here hopefully realize that this part is equal to -16 because we have to follow order of operations, right? So what happens is a lot of kids, when they see this, they'll think that this is equal to -2 to the power of 4, which is equal to +16 because -2 times -2 times -2 times -2 is +16. And again, that's not true because when we follow order of operations, we actually need to do this exponent first, which is 2 to the power 16. And then afterwards, we apply the negative sign, which is equivalent to multiplying it by -1, right? So our final answer here works out to be -16. And then we can do this component. So -1 minus 1, which is -2 to the power of 3, plus 5 times -2 to the power of 4, which is 16. Okay, so we have -6, take away 8, plus 80 as our final answer. And again, -6 take away 8 is -24, plus 80, and our final answer works out to be +56. Hopefully this is the answer that many of you got. And my recommendation is once you're at the high school level, to try your best to show your work. So I don't know if you guys are currently showing your work or if you guys are used to showing your work at school, but try to write your equations in a top-down manner, sort of like a upside-down triangle like this. Or I don't know if you could call that a right side up triangle, depending on how you look at it. And then try to write each line separately to indicate all your steps, okay? So this becomes this, which then becomes this, so on and so forth, until we get to the final answer. You will lose some marks in communication if you don't show all your steps. This is more important at the elementary level, I think. So for those of you who are in grade 6 or going into grade 8, grade 6 or grade 7, get used to showing all your steps because the teacher will likely take off marks for not showing it. At the high school level, if you wanted to jump straight from this step all the way down to this step, it might be acceptable. You might be able to do it all in one, but you probably still need this step, okay? So you can probably do it in 3 steps at the high school level, 1, 2, and 3. That's probably okay because this just becomes very simple arithmetic and the teacher might assume that you can do all of this in your head. So that's fine, okay? At the elementary level, most likely your teacher is gonna want you to show all your steps. So for our grade 6 and for our students going into grade 7 and going to grade 8, my recommendation is to show all your steps for these type of questions, okay? But integer operations should be fairly straightforward for everybody. And if ever you guys have questions about how to add or subtract integers, my recommendation is still to visualize the number line inside your head. And remember, whenever we subtract, we're going towards the left, and then if we're adding, we're going towards the right, okay? Generally speaking, I think everybody knows this quite well at the elementary level, and if you do make a mistake, it's not usually due to lack of understanding, but rather due to careless mistakes. So that's something that if you guys are having trouble with, make sure to just be a little bit more careful in the future, okay? This is stuff that you've already learned from elementary as well, and this is just straightforward substituting for the variable. And again, we're not gonna do that because that's really, really easy. You literally just plug in the x and y. Okay. Let's see if we can learn something else that you wouldn't have learned in elementary level yet. Okay, so they're calling it extension, but we're going to get to that section soon. Okay, so this section is on rational numbers. It's kind of a fancy word, but who knows what a rational number is? Who knows what a rational number is? It's a really fancy term for basically just anything that can be expressed as a fraction. So as long as you can express it as a fraction, it is a rational number, okay? If something cannot be expressed as a fraction, then it's probably not a rational number. So that's basically it. They won't really ask you this definition. And it's really more just about the same thing that we did up there, except previously we were working more with whole numbers when we were doing the integer operations. This time we're not working with whole numbers anymore. So they're no longer integers, they are rational numbers because they're fractions, okay? So this chapter is very much a review of all the previous chapters that we learned. So they're like the 3 chapters where we did the addition, subtraction, multiplication, and division. And now you have negative components incorporated within it. But I still believe that this is quite easy for everyone here. Everybody here is aware that a negative number times a negative number or a negative number divided by a negative number is a positive number, right? Everybody understands this concept. I do believe that you would have already taught it, so it shouldn't be difficult for everybody. Okay, so I don't think we will have, again, rational order of operations. It's very similar to what we've done. I'm trying to find something new for you guys. So let's just jump straight to chapter 2, because that's when we start learning about the exponential rules. And again, if you have anything here that's a little bit more difficult, that you don't understand, we will be reviewing it in the first week once we start the actual math lesson, because that's what you do in grade 9 math to start with. They review grade 8 material for you real quick. But this might be, some of you might already know it, but I do want to teach you guys something new today so that you can take it with you once you leave the lesson. So this section is called multiplying and dividing by powers. These bases, when we're talking about multiplying and dividing by powers, they're usually going to assume that we have the same base over here, okay? And that's all that we're going to learn at the school level, I believe. So we're not going to learn anything very complicated. When we are multiplying numbers with the same base, what you could do is you could actually just add the exponents together. So for example, if we have 3 to the power of 6 times 3 to the power of 9, this is effectively equivalent to 3 to the power of 6 plus 9, which is 3 to the power of 15. Okay, so I don't know if, generally speaking, they won't teach you guys this in grade 7 or 8. So this might be something that's a little bit new, but nonetheless, it's still fairly straightforward. When we're multiplying two numbers with the same base, we can add the exponents together. Now, you guys probably can already guess, but what would happen if we need to divide numbers with the same base? Well, you probably already guessed it, but you would actually subtract the exponents, right? So this equation right over here, even though it looks fairly big, and we don't want to, if we can actually solve it without using a calculator, because the final answer just works out to be 3, which is 27. Okay. Sorry, Mac, I might ask you to just mute your microphone because I can hear you talking at the back, okay? Nice of you to join, though, Mac. It's nice to meet you. I'm Michael. So what happens is this concept of addition and subtraction of the exponents together, generally speaking, is new and is not taught at the grade 7 and 8 level. So hopefully this is something new for you guys. And let's try a practice question real quick just to make sure everyone understands how to do this. And then I'll give you guys a question from my own notes and see whether or not. It's not new. You guys learned this? You learned this before at elementary already, Eric? Or you mean it's not difficult? I'm not sure what you mean by it's not. Yes. Again, try writing in complete sentences. That's my recommendation for you. If you just say yes and no, sometimes people get confused. Okay, but that's okay. So let's do 2 to the power of 3 times. I think you've seen this before in your books. Yeah, okay, that's great. If you've seen this before in your books, that's fantastic. Okay. And then eventually you guys are going to learn what happens when there's a power to a power. Like you have 2 to the power of 3 to the power of 3. And you guys probably guessed it already, but you would actually just multiply the exponents together. So this can be rewritten as 2 to the power of 9. That's known as power to power. Okay. Right now we're dealing with just multiplying of the same base. So let's practice a few of these because I think this is new for most of you, but still it's very, very easy. And I did want to give it to you guys so that you can leave the lesson here today having learned something new instead of just doing all review, right? We don't want to just do all review every time that we're here. So who can tell me the answer for this one? You don't need to give me the actual answer, just simplify. That's all they're asking for. What can this be rewritten as? Yep, Antonio.
2 to the power of 5.
2 to the power of 5 is correct. Good job. And similarly, why don't we try this one? This one's a little bit more complicated. So we have 5 to the power of 5 times 3 times 3 to the power of 4 all over 3 to the power of 3 times 5 to the power of 4. Who can tell me what this one would be? You can, again, just simplify. You don't need to actually give me the numerical answer. But what could this be simplified to? Sorry, Mac. Can you just mute yourself, please? So, Karina, can you tell me the answer for this one? Or Eric or Alex. One of you three. Doesn't matter who. What can we simplify this to before? Alex has seen this before in his books. So he should be able to do it.
So 3 to the power of 5?
So the top, you want to simplify it to 3 to the power of 5. Very good. And then we're obviously going to keep this. So what else can we simplify it to? 5 times 3 times 3 is Chang's final answer. That is correct. Really good job. So afterwards, we can still simplify this, right? Because we have 5 to the power of 5 on top and 5 to the power of 4 on top. So this just becomes 5. 5 to the power of 1, right? And then again, we have 3 to the power of 5 divided by 3 to the power of 3, which just becomes 3 to the power of 2. So this is our final answer. The final answer is 5 times 9, which is 45. Okay. Hopefully everybody understands this concept, and hopefully it's new for everyone, and you guys will be able to apply it towards your grade 8 lessons, because it's useful even in grade 8. It's just that it's not explicitly taught. What about this question? So I'm just going to ask you guys to simplify this. Again, there's no need for you to give me an exact answer. So we have n times n times n times dot 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 times n. I'm going to multiply n times. Okay, it's going to multiply by itself a lot of times. Maybe I could just move you. Oh, I just realized I can move. Okay, sorry about that. N plus n plus n plus dot 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 dot, and then plus n over here. And we had itself n times. What does this simplify to? So again, it's just building on the rules that we already know, okay? All of you should know how to do this question based on what we taught already. How do we simplify this question? What's my final answer? Give you guys 1 minute to think about it, okay? And then afterwards, I'll try and call on some people for the answers. To those of you who just joined, nice to meet you. My name is Michael. We're just doing a very quick introduction lesson to grade 9 math today. So hopefully you guys enjoy it. JWN, I think I saw an Aaron before too. Yeah, Aaron A. If there's anything that you guys haven't learned before and it's very difficult, you guys have to let me know so that I can slow down and explain it to you, okay? Otherwise, I'm operating under the assumption that you guys have learned the fundamentals before, and that we will be able to move on a little bit quicker. Okay. So let me call on some people. I'll call on Eric first. Eric seems to, Eric, what would my numerator be simplified to? You don't think you learned this type? It's the same type. There's no different types, Alex. It's the same type. If I just wrote this as, if I wrote, instead of n here, I wrote 2 times 2, you would probably immediately tell me this is 2 squared, right? If I wrote 2 up there, you would probably immediately tell me this is 2 squared. But I don't want to write 2 this time. I want to write it as a variable. I want to write it as n. So what would my numerator be if I have n times itself n times? What would my numerator be simplified to? Can anybody tell me? I'm opening up the floor to everybody now. Who can tell me what the numerator would be simplified to? And again, if I wrote this as 3 times 3 times 3, you guys would immediately tell me this is 3 to the power of 3. N to the power of 3? It's not quite to the power of 3. Remember, we're multiplying it by itself n times, not 3 times. If it was n times n times n, that would be n to the power of 3. You're correct. But here, we're not multiplying it by n to the power of n. Good job, everyone. Very good. So the top simplifies to just n to the power of n. What about the bottom? Who can simplify the denominator for me? Good work, A. A, can you tell me what the denominator was simplified to? Sorry, I don't know your name. I'm just going to call you by your handle, A there. What would the denominator be? Good work, Chang. That's correct. Who knows what the denominator would be?
N times n.
N times n, very good, because we have n adding itself n times, right? It's almost like if I said 2 plus 2, you would immediately tell me this could be written as 2 times 2. Or if I have 3 plus 3 plus 3, you would tell me that this could be rewritten as 3 times 3. So this is actually n times n. So we have our this, okay? Who can now solve for the final step in how to simplify this? There's only one step left, and we learned about this. What is my final exponent up here? How do I rewrite this so that it only has one base? N to the power of? What do we do when we're dividing by the same base? N minus 2 is correct. Good job, Chang. Does everybody see how this whole thing, nobody would ever write this, right? It's just a math question, right? This whole thing can be rewritten as just this. Does everybody understand this concept? Alex and Eric, Karina, you got it, good job. Eric, sort of. Okay. Eric, all you have to do is think about it. If you're ever confused, substitute n with a number so that you have 2 times 2, and you can rewrite it as 2 squared. I know that you understand this concept. Okay. Similarly, if we have 2 plus 2, we can rewrite it as 2 times 2. So I know that you understand this concept. So now if we have n times n, it's obviously n to the power of n, and obviously n plus n times will be rewritten as n times n. So our final answer is n to the power of n minus 2. Okay? It's really good job. So that question would basically cover all of this. Okay? Because all of this is just talking about the exact same exponent rules that we covered a little bit earlier with that question, which is multiplication and division of same base exponents. Okay? What about application of it? Like, why do we need to learn that? Seems kind of useless, right? Like, yeah, it kind of is useless. It's not super useful because we could always solve it with the calculator, but we want to try and do it by hand if possible. So let's take a look at a potential question. What if I have something like this, and then the teacher on the test said no calculators allowed? Okay, solve for n. Who can tell me the answer to this question? Again, my recommendation is simplifying the left side first. Okay.
Isn't it a third? I mean, a half, a half?
A half is correct. Good job. So it's not a third. How did you get that answer? What's your thought process?
Well, I know 2 cubed is 8, and 1 was pretty easy.
Okay, that's a very good thought process, actually. I like it. But here's how I would do it in case that it's hard for us to visualize what 2 cubed becomes 8. So I would first simplify this to become n cubed. And now I know n cubed is 1 over 8. Therefore, n must equal to the third root of 1 over 8. And again, if you guys haven't learned the third root yet back in elementary, now's your chance to learn about it. Because the third root basically says some number multiplied by itself 3 times would give me 1, and some number multiplied by itself would give me 8, right? So this actually works out to be 1/2, because 1/2 times 1/2 times 1/2 gives me 1 over 8. Okay? So therefore, the third root of 1 over 8 is equal to 1/2. Okay? Similar to the concept of square root that you guys learned before. So a square root actually has an invisible 2 here. That's why we call it a square root. But people are lazy, so we never write the 2. But technically, there's actually an invisible 2 here. And for example, if we had the square root of 1 over 4 is 1/2, because 1/2 times 1/2 gives you 1 over 4. Okay? And then you can have a root to essentially any, to the nth degree, essentially. Okay, so this is known as the third root, and that means you're trying to find a number that would multiply by itself 3 times. We give you the resulting number inside. So our final answer for this one will be 1/2. Okay, what about this one? This one's a little bit more challenging. Try your best. So this one is 2 to the power of x times 2 to the power of 7 becomes 128. Okay, so here's the question. I'll type it so that I don't have to, you guys don't have to read my horrible handwriting on the computer. So how many possible values are there for x, assuming x is a positive integer? Okay, guys, in case you can't read it, that's a 7, okay? That's a 7. So 2 to the power of x times 2 to the power of 7 gives me 128. How many possible values for x are there? Oh, I'm sorry. This question is too easy. Let's change this up. Change this to y. Okay. So 2 to the power of x times 2 to the power of y equals to 128. How many possible values are there for x? My fault. I couldn't read my own writing. Okay, make that better. Zero is not the right answer. There's definitely at least one possible value for x. Oh, that was before. I apologize. Oh, when it was 7, there was no possible values. No, that's not true either. I don't think that's correct either. There's still one possible value for x, right? X has to be equal to 0. Oh, did you mean x has to equal to 0? Okay, I'm not asking for the value of x. So you have to read the question carefully. I'm asking how many possible values are there for x? So if the value for x was 0, that means there's one possible value. Okay? So for this particular question, you're not going to be able to solve for the different, well, I guess you could, but how many different combinations of x and y could there be in order for us to solve for this, in order for this to stay true? Assuming that x is a positive integer. So Chang says there's 8 combinations. Eric says 1. A says 7. So everybody has a slightly different answer. So let's see 7 maybe. Okay, so we're getting mostly 7. So I think 7 is most likely the correct answer. So let's double check and see whether or not the answer is 7. So who can tell? A, can you tell me how we solve this problem? Or maybe Mac? Both of you are new to the classroom and both of you guys said 7. So what's your first step in solving this problem? Again, you can type it or you can say it. It's up to you. What's our first step in solving this problem? Is it 2 times 1? I'm not sure what you mean by 2 times 1. Because I'm asking for how many possible values for the x are there. So it must be some kind of whole number. It must be like 1, 2, 3, 4, 5, or 6. I'm not sure what 2 times 1 means. So again, we'll take it up right now so that we can work through it together. But who can tell me what is the first step, Karina? Or Mac or A? Because A and Mac, you guys both said 7. How did you guys get 7? It might be the right answer, so you don't need to be shy. X equals to 0, 1, 2, 3, 4, 5, 6, 7. Sheng, look at the question again. I can see what you're saying. X has to be a positive integer. So right away, if any of you guys have 0 in your answer, it's already wrong. 0 cannot be a possible value for x because x has to be a positive integer as stated in this question. Okay, 0 is not a positive number. So can't have 0. Okay, what would your revised answer be? If any of you guys thought that 0 was a potential answer, I'm telling you right now, 0 is not a potential answer because I only want positive integers. So I'm restricting the solution set a little bit. Oh, Max got it. 2 to the power, so x lies between 0 and 7. Okay. So you guys all have the answer. You guys all have it somewhat correct. I think everybody here would probably, if I was marking it, I would give everybody half mark. So good job. The first step that I would like to see from the students is that we're applying our knowledge. So again, 2 to the power x and 2 to the power y can be re-simplified as 2 to the power of x plus y. Everybody should have written this as their first step. Okay? 128 can be rewritten as base 2. What can 128 be rewritten as? How do we rewrite 128 as base 2? 2 to the power of what?
7.
7. Okay, good job. So that means these two exponents must be equivalent, right? 2 to the power of something must equal to 2 to the power of 7. Therefore, this something must equal to 7. Does that make sense to everybody so far? So again, everybody is telling me 7 is the different possible combinations. So you're saying x can be anywhere between 1, 2, 3, 4, 5, 6, or 7, right? It should be 6 on 7. It can also be 0. It can't be 0 because that's the same thing that I just told Cheng. X has to be a positive integer. Okay? So x has to be positive. So the final answer is x can be 1, 2, 3, 4, 5, 6, or 7. Does that make sense? The 0 is not applicable. Does that make sense to everybody? I don't say anything about the restriction for y, so y can be 0. It doesn't matter. Okay? But how many different possible values are there for x? The answer is 7 possible different values. Everybody understands this concept? And again, I feel like a lot of you got the final answer correct, but it's a matter of showing your work and doing the communication. And showing your work this way is something that will probably be able to get you a little bit higher marks. I'm not going to say you're not going to get marks for the previous solution, but if you show your work this way, and this is applying the knowledge that you've just learned, this shows that x plus y must equal to 7. Since x must be equal to a positive integer, x cannot equal to 0 or any negative numbers. Therefore, x is limited to just 1, 2, 3, 4, 5, 6, or 7. Okay, and therefore we have 7 different data sets that we can use for the value x. Okay, hopefully everybody found this question interesting. This is more why we need to learn about grouping and simplifying for these various different types of exponents with similar bases. And this is a concept that you'll be using all the way through grade 10, grade 11. Where you have to group certain terms together. Even grade 12, once you learn logarithms, this becomes very, very important where you have to realize that, well, if we can express the numbers as equivalent bases, then we can just compare the exponents, okay? So hopefully you guys learned a little bit something today and you guys are able to walk away with it and apply it towards your grade 8 knowledge. If you didn't, it's okay. It's something that that just means your math is that strong, right? You already learned all of this before. So that's it for the trial lesson today. I hope you guys enjoyed it. I'm not sure if Michael is still here. I know he usually likes to say goodbye to all the kids. Doesn't seem like Michael is here anymore. Thumbs up. Thank you so much, Alex. So that's it for today. Hopefully you guys enjoyed the lesson. And if you did, you guys can contact Michael to see whether or not you guys are ready for grade 9 math, or if you guys don't feel you're interested in grade 9 math, we are potentially running a grade 7 and grade 8 math class on Saturdays, I believe. But for the majority of the students that I've seen here, I believe it would be too easy. And I do think most of you are probably more than sufficient to move on into grade 9 math. Okay, so really strong math from everyone today. Good work, and enjoy the rest of your day. It's almost back to school, so make sure you guys have fun, okay? You're going to grade 6. Yeah, you and someone else are going to something really, really low. You guys have really strong math, so really good job. Keep up the good work. Yeah, you and Eric, you guys are too smart, okay? So wherever you guys are learning from your math, even if it's your parents, it doesn't matter. Tell them that they're doing a great job, and I hope that you continue to learn math and enjoy math, okay? That's it for today, guys. Enjoy. Bye. I'll say bye to you guys on behalf of Michael from Mentors, okay? Take care. Thank you so much for everyone for participating today. Really good work.
Thank you. Bye.
Thank you. Bye.
Thank you. Bye.
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 Okay. Bye. Everyone's so polite. Bye, guys.